My name is Ben and I do developer relations at Gelato. Today we're going to be looking at gasless cross-chain transfers powered by our relay service, Gelato Relay. First of all, a quick introduction to Gelato. Gelato is Web3's decentralized backend, empowering builders to augment their smart contracts to create reliable, user-friendly, and scalable Web3 applications without sacrificing decentralization and censorship resistance. You might be wondering why we even need, a Web3 decentralized backend stack when we already have exactly that in the form of smart contracts. And this is true, but as your application grows and you may want additional functionality, you may find that just isn't possible with the current just smart contract stack. So the way we envision Gelato's decentralized backend stack to look like is we have, our original front end, we have some smart contracts, but in addition, we can use Gelato services to, for example, allow for smart contract automation using Gelato Automate. So you can have smart contracts execute, for example, every second or whenever user-defined criteria is met. You can use this to check a user's health factor and liquidate them when it gets too low, for example. The second service we offer, and the one I'll be focusing on in this talk, is Gelato Relay, which allows developers and users to easily put transactions on-chain in a gasless manner, so you don't need native tokens in order to do so. The nice thing is this also abstracts away a lot of blockchain complexities. You don't have to worry about resubmitting failing transactions, you don't have to worry about block reorgs, and you don't have to worry about finding reliable RPC providers. Our third service and the latest service is Web3 Functions, which is similar to Automate in a way. It allows you to access and index on and off-chain data. So you can use this to interact with traditional Web2 APIs and push their data on-chain. A really common use case of this is Pyth, for example, where you can push price oracle prices on-chain. And you might also have some data storage solution other than storing the data off-chain. For example, IPFS, you can use it to store NFTs. It's also worth noting that our Web3 functions are written in TypeScript, and they're actually stored on IPFS as well. So we use it ourselves internally. The agenda for the next sort of 15 minutes is to discuss the cross-chain transfer protocol by Circle, also known as CCTP. I'll discuss what it is and how it works. Then I'll discuss Gelato Relay, again, what it is and how it works, and also how it's useful in this case. And then I will discuss what we're releasing, which is the gasless CCTP SDK. This will make more sense as I go through the first two. And then I have a sort of live demonstration. I didn't know how good the internet was going to be, so it's actually a live video demonstration, but it should suffice. So first of all, what is CCTP? So CCTP is Circle's cross-chain transfer protocol, and it is a permissionless on-chain utility that facilitates USDC transfers between blockchains via native burning and minting. And this is taken directly from Circle. Essentially what it means is that it's a permissionless bridge for USDC. The key thing to note here is that it's native burning and minting. So the benefits it has over traditional bridges is that there's no need to lock and mint tokens. So traditional bridges, if you're bridging USDC from Ethereum to Avalanche, you have to lock up the USDC on Ethereum, and then you get minted some synthetic version of USDC on Avalanche. The way CCTP does it is because USDC is issued by Circle, we can actually burn USDC and we can natively mint USDC as well. And what's really nice here is we don't have to worry about synthetic tokens, whether they have backing, etc. And also we unify liquidity. So we don't have USDC locked up on multiple blockchains and then synthetic tokens all over the place. Instead, we just have USDC, which is burnt and then natively minted. This also decreases sort of the attack surface because there's no smart contracts, sort of like honeypot smart contracts, which hold large amounts of USDC. Now, how does CCTP work? The first step is burning USDC on the source chain. This will emit an event which Circle is listening for and observes. And once they wait for a couple blocks to pass, they wait for block finality, and then they issue an attestation signature, which you can query through their API. Then you can go and fetch this attestation signature and use that to mint USDC on the destination chain. And obviously, the amount of USDC you burn on the source chain is the same as the amount of USDC you're allowed to mint on the destination chain. And this is really cool, but it has some limitations. Those being that steps 1 and 3, so burning USDC on the source chain and minting USDC on the destination chain, both require a transaction on-chain, which requires native tokens. And this is a bit of a hassle because you can imagine if you're moving USDC from Ethereum to Avalanche, for example, you might not actually have AVAX on Avalanche in order to actually transfer the USDC. Another sort of pain point or limitation is that subsequent transactions on the destination chain also require native tokens. So even if you somehow manage to move the USDC from Ethereum to Avalanche, you still need native tokens in order to even interact with it. So the bottom line is that whilst USDC is free to move around chains, the native tokens we need in order to actually transact are not. So the vision that we have is that imagine we could move USDC between chains and cover the associated cost using the USDC which is being transferred. So on the source chain, we can use some of the USDC we're burning to pay for the transaction, and then on the destination chain, we can use some of the USDC we're minting to also pay for the transaction. And then in addition to that, we'd like to be able to pay for subsequent transactions on the destination chain also using USDC. So once we've moved the USDC from one chain to another, we can continue using USDC to cover all of the transaction fees. So we eliminate the dependence on native tokens, and that gives us infinitely more freedom. The implications being that USDC now acts as an interoperability layer connecting multiple chains, and it also eliminates the need for per-chain native tokens. So in a sense, USDC now acts as a sort of universal fee payment token or transaction payment token. And this is not just a vision, this is possible using Gelato Relay. Gelato Relay is a relay service which enables gasless transactions on all major EVM compatible networks. So the networks I mentioned earlier, Ethereum and Avalanche, and yeah, any network you can name pretty much which is EVM compatible, we also support. Let's sort of zoom out a little bit. First of all, let's discuss what is a relay even. By definition, relay means to receive something and then pass it on. In our case, more specifically, sort of in the context of Web3, it's an EOA executing a transaction on someone else's behalf. So the relayer receives the transaction and passes it on or puts it on chain. Now, more specifically, what is Gelato Relay? Gelato Relay is simply a decentralized network of relayers, so of these relayers, otherwise known as executors, and it can also be considered a marketplace which brings together two parties. The first party being the developers, which want to streamline the user experience by making their transactions gasless, and the second party being infrastructure operators, which execute these transactions for a small fee. So it's sort of a win-win. What are the implications of relaying a transaction? The first and really nice implication is that because the relayer puts the transaction on chain and not the user, the relayer also incurs the associated gas fee and not the user. This is really nice because it gives us unlimited freedom in how we want to handle payments. So obviously the relay needs to be compensated, but how we want to compensate the relayer is, we have lots of freedom in that. So transactions can either be self-paying. We can pay for a transaction as it's executing using any sort of tokenized asset. So we can use USDC to cover the transaction fee as the transaction is executing. We're no longer limited to using native tokens like Ethereum or AVAX. The second mode of payment is by having sponsored transactions. This is sort of like a deferred payment where you can top up a balance. This is our one balance service, which allows you to pay for transactions across all networks and across all of our services. And the nice thing is that we're no longer restricted to paying in native tokens, like I've mentioned, but we're also no longer restricted to paying at the time of execution. The second implication, and sort of a caveat in a sense, is that the relay who's executing the transaction is actually the message.sender and not the user from the perspective of the contracts that we're interacting with. So one problem that arises, and this is just one, is that how can we, for example, approve USDC spending if the transaction is coming from the relayer? If the relayer were to execute it, the relayer would be approving spending of his USDC, not the user's USDC who requested for the transaction to be executed. So what is the solution? Could we just have the user execute an approved transaction in advance? So put this transaction on chain and do like an infinite approval. Well, first of all, infinite approvals are sort of an anti-pattern, which is not very nice. But sort of the main issue is that this requires gas and defeats the entire purpose of this. So what is the actual solution? And there are some nice standards in place which we can use. Among others, for example, EIP 712 and ERC 2771. Sort of broadly speaking, these are cryptographic signatures which we can sign off-chain, and that doesn't require any gas, so we can use the private key associated with our EOA to sign a transaction, and those can then be verified on-chain by smart contracts. So rather than approving an ERC20 token, we can use permit on ERC20 permit tokens. USD is one of which. So here's the flow, sort of what I explained earlier, but in a sort of visual form. We can relay the first transaction to burn the USDC. We can then wait for an attestation signature. On the front end, we wait for block finality, etc. And then we can relay the second transaction on the destination chain to actually mint USDC. If we sort of zoom in on just a single relay transaction, what it looks like, this is actually for a gasless NFT mint, but it's just a bit simpler to sort of demonstrate, but the same applies for the USDC example as well. So we can imagine a wallet which has 0 Ethereum, so it's not able to transact, but what the wallet can do is it can build this mint transaction, and then it can sign it using its private key. We can then send this over to Gelato, either using the Gelato API or using the SDK we provide. One of the executors on Gelato's network will then pick up the transaction and then move it from the off-chain world to the on-chain world, so actually execute the transaction. We can then have, for example, a trusted forwarder on-chain, essentially doing signature verification. It can verify the signature first of all, that's the first step, and then it can also recover the original signer of the signature. So we preserve this notion of like a message.sender. And then we can forward all of this to the NFT contract, which can then mint the NFT to the user since it actually now knows who the user is. And obviously I don't expect anyone to remember all of this in sort of great detail, and you shouldn't have to, which is why we're introducing the Gasless CCTP SDK. This is built on top of Circle's CCTP and also on top of our Relay service. And you can find this on GitHub, github.com/gelatodigital/gasless-cctp. And essentially this sort of exposes a really simple interface where any dApp developer can integrate this into their dApp. So you call this transfer method, you pass an amount of USDC you'd like to transfer, including the fee amounts. There's 2 fee amounts, one on the source chain and one on the destination chain, and you can specify what max fee amount you're allowing on the source chain and then on the destination chain respectively. You also provide a chain ID. This is just the chain that you want the USDC transferred to. And you also pass a wallet. This wallet allows us to sign the transaction off-chain, and it also has a source chain RPC provider so we can get some on-chain state from the source chain. It's also worth noting this is not just useful for bridges, but also if you imagine an NFT marketplace which is sort of Avalanche native, but it wants to support USDC payment from other networks like Ethereum or Arbitrum, etc. It can easily integrate this, and it can offer exactly that, all whilst remaining Avalanche native. So there's not much work required on sort of the developer's end. Here's the full code sort of implementing this example here. This is the snippet I showed in the previous slide. And this works, there's not really much more to it. The only additional code is that we instantiate an RPC provider, a JSON RPC provider, and we also instantiate a wallet with a private key and with this RPC provider. And then we pass the respective arguments and transfer USDC, in this case 100. So now for the demonstration, the sort of live video demonstration. I didn't have time to make a front end for this, but this is sort of demonstrating in a hard hat project. So yeah, in this case, we're moving USDC from, one second. We're moving USDC from Avalanche to Arbitrum. And in this case, we're moving 5 USDC, and we're allowing a max fee of 1 USDC on the source chain and 1 USDC on the destination chain. I'm just showing the wallet balance before the transfer. So on Avalanche, we have 5 USDC. And then on Arbitrum, we have no USDC whatsoever, and we can also imagine that we don't have any native tokens on either of the networks. So 5 USDC on Avalanche. If I run this, so just to reiterate what's happening is that we've relayed the first transaction which burns the USDC on the source chain on Avalanche. And once that's gone through, we'll see that the USDC disappears from our wallet. MetaMask takes a second to update. Yep, so the USDC is now gone. We transferred 5 USDC, so we're left with 0.5. And now what's happening is that Circle has listened for this event, and now it's waiting for block finality on Avalanche. In Avalanche's case, it only waits for 1 block, which is around 20 seconds, before issuing the attestation signature. And then once we receive this attestation signature, we can use that to mint USDC on the destination chain, in this case Arbitrum. So I'm just looking at Arbitrum now. Our balance is still 0, but once this transaction goes through, we'll see the balance go up. Bear in mind, we transferred 5 USDC. and some of it is used for fees. So in this case, 4.5 USDC has arrived on Arbitrum, which means that 0.5 USDC was used for the transaction fee payments, both on the source chain and on the destination chain. And it's worth noting that obviously this is sort of an absolute value, which is the nice thing about crypto in general, is that even if you're transferring, a billion USDC, you're still going to end up paying the same amount, so still 0.5 USDC. Yeah, just to sort of wrap up as a conclusion, our other services, which I mentioned earlier, we have the automation service, which does on-chain automation, and it allows you to perform computation without requiring user interaction. So we can use this to, for example, fill limit orders without the user having to sit at their PC and fill it manually. We can use it to liquidate users, etc., etc. And then our second service, which is this Web3 function service. These are very general functions written in TypeScript. We store them on IPFS, and they're run by our decentralized network of node operators. And these allow us to bridge the gap between multiple chains, because we can access chain state from multiple chains, and also bridge the gap between the on and off-chain worlds. So like I mentioned earlier, we can push prices on-chain, like price order prices. And all of these services can be self-paying or sponsored by our one-balance service. So that's up to you as a developer. Thank you for listening. If you'd like to check out our website, it's gelato.network. We have a Discord if you have any sort of questions. Maybe you want to use this during the hackathon, you have any questions, feel free to ask us on Discord. Our Twitter is Gelato Network, and my Twitter is Ben Price with a V at the end. Yeah, let me know if you have any questions. Thank you. Yeah, that's a really good question, actually. Yeah, sort of unrelated, like you said, but yeah, exactly. So what you can do when you set up a Relay application is you can specify which functions you want sponsored. So if you only want to allow users to, for example, if it's an NFT, for example, and you only want to allow them to mint and obviously not just execute any transaction and use your balance, you can just whitelist this mint function on your smart contract. So yeah, you do expose the API key on the front end, but there's nothing the user can do with it other than mint your NFT, if that makes sense. So yeah, okay. Thank you.
I have a question. So you said you don't need to worry about the reliable RPC providers using a relayer. Why is that? Do you run your own nodes maybe?
So we're in touch with lots of RPC providers, and we sort of aggregate them. So if one of them goes down, we'll just fall back to the second one, fall back to the third one. So that's sort of more reliable. Obviously, you can do this yourself, but it's something you'd have to sort of implement manually, and it's quite a bit of hassle, especially keeping up with who's the most reliable, etc. Yeah, it's similar in a way, so that's a great question. You can either pay the relayer back. As your transaction executes, you can transfer some token to a fee collector, and we'll check the balance before and after of this fee collector to make sure that you've paid for the transaction. The nice thing is that in this case, you can pay using USDC. You don't have to use like Ethereum, for example, or any native token. And the second thing is that we have a one balance system where you can deposit USDC on Polygon, and you can use that to pay for all transactions across like any network, and also across all our services. So not just the Relay service, but also Web3 functions and Automate, etc.
And is there a possibility for the applications to do that on behalf of the user, so the users don't have to pay for it?
Exactly. So the first thing I mentioned, the synchronous fee payment, the user is paying. But the second one is this one balance system where you can decide to sponsor the transaction. So you can imagine an NFT project wants to make the mint free to like reduce or make it like a very seamless experience. You can also imagine like lots of gaming use cases. Where you just want the user to be able to start playing your game without having to worry about, acquiring these like native tokens, etc. So, yeah.
Cool.
Thank you very much. Yeah. Yeah. Okay, say again, a little bit louder. Yes, we support testnets. We're on Gurley. I think we're launching other testnets, but yeah, we support lots of testnets. Mumbai, etc. Like all the testnets, pretty much. So we're not related sort of like that. We have like a pretty close relationship, but it doesn't relate to Circle. Anyone can do this. In our case, we're just sort of demonstrating the Relay service. Because usually what you'd have to do if you're just using CCTP, you'd have to put the source transaction on the source chain to burn the USDC, and then on the destination chain to mint the USDC. And you'd be paying gas along the way for both transactions. So what we do is we sort of abstract that away. It's like one click for you, and you can transfer the USDC to a different chain. So it's sort of a demonstration of both. It's built on top of both platforms. Any other questions? Okay. Thank you very much.